Listen to part of a lecture in a biology class.
Well, it's finally looking like spring is arriving. The last of the winter snow will be melting away in a few days. So before we close today, I thought I'd mention a biological event that's part of the transition from winter to spring. Something you can go outside and watch if you have some patience. There's a small creature that lives in this area. You've probably seen it. It's the North American wood frog. Now, the wood frog's not that easy to spot since it stays pretty close to the ground, under leaves and things, and it blends in really well with its background, as you can see. But they're worth the effort because they do something very unusual, something you might not have even thought possible. Okay, North American wood frogs live over a very broad territory, or range. They're found all over the northeastern United States and all through Canada and Alaska, even inside the Arctic Circle. No other frog is able to live that far north. But wherever they live, once the weather starts to turn cold and the temperatures start to drop below freezing, as soon as the frog even touches an ice crystal or a bit of frozen ground, well, it begins to freeze. Yes, Jimmy, you look a little bit taken aback.
Wait, you mean it's still alive, but it freezes? Solid?
Well, almost. Ice forms in all the spaces outside cells, but never within a cell.
But then how does its heart beat?
It doesn't.
But how can it
do such a thing? Well, that first touch of ice apparently triggers a biological response inside the frog that, first of all, starts drawing water away from the center of its body. So the middle part of the frog, its internal organs, its heart, lungs, liver, these start getting drier and drier, while the water that's being pulled away is forming a puddle around the organs just underneath the skin. And then that puddle of water starts to freeze. Okay, up to now, the frog's heart is still beating, right? Slower and slower, and in those last few hours before it freezes, it distributes glucose, a blood sugar, throughout its body, its circulatory system. Sort of acts like an antifreeze.
A solution of antifreeze, like you put in your car in the winter?
Well, you tell me. In frogs, the extra glucose makes it harder for the water inside the cells to freeze. So the cells stay just slightly wet, enough so that they can survive the winter. Then, after that, the heart stops beating altogether. So, is that the same?
I don't really know, but how long does it stay that way?
Well, it could be days or even months. All winter, in fact. But, see, the heart really doesn't need to do any pumping now because the blood is frozen too.
I guess I just don't see how it isn't, clinically dead.
Well, that's the amazing thing. And how it revives is pretty amazing too. After months without a heartbeat, springtime comes around again, the earth starts to warm up, and suddenly, one day, ping, a pulse, followed by another one, then another, until maybe 10, 12 hours later, the animal is fully recovered.
And does the thawing process have some kind of trigger as well?
Well, we're not sure, actually. The peculiar thing is even though the sun is warming the frog up on the outside, its insides thaw out first, the heart and brain and everything. But somehow it all just happens that way every spring.
And after they thaw, does it affect them, like their lifespan?
Well, we really don't know a lot about how long a wood frog normally lives, probably just a few years. But there's no evidence that the freezing process affects its longevity. It does have some other impacts, though. In studies, we found that when it comes to reproduction, freezing diminishes the mating performance of males. After they've been frozen, and thawed, of course, they don't seem quite as vocal. They move slower, and they seem to have a harder time recognizing a potential mate. So, if a male frog could manage not to go through this freezing cycle, he'd probably have more success in mating.